Data may be the lifeblood of modern business, but harnessing it efficiently gets harder by the day. Two related disciplines are evolving to address this situation: data fabric and data mesh. The former is all about integration, automation, and unification. The latter embraces decentralization and agility. Which is right for your organization? Or can you do both? Learn more on this episode of Future Proof.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Yours truly, Eric Kavanagh, is here with an all-star panel. We've got Steve Sarsfield from OpenText, Vertica on the line, and my good buddy Eugene Burke from Digital Strategies Group. We're going to talk about data mesh versus data fabric. Cut from the same cloth? Short answer is yes. So for our broad listening audience out there on the radio, data fabric, data mesh, these are relatively new concepts, and really they're sort of extrapolations of the database. We all know a database runs basically every application that there is out there. Databases have been around for decades now. I mean, really for probably 60 years, if you go all the way back, maybe close to 70 years, we've had database technology. And there have been tremendous advances in the database space, especially over the 10, 12 years leading up till today. So I remember when the Hadoop thing came around. So some of you may know there's a concept, a construct called Hadoop. And basically that was how Yahoo would index the web. And then there was open sourced, and a number of companies jumped on it, like Cloudera and Hortonworks. A company called MapR jumped on it. MapR got absorbed by the Borg, I think it was HP, a number of years ago. Cloudera is still around, but they absorbed Hortonworks, which was odd because they were staunch, nasty competitors. And then they sort of merged. They're doing some interesting things still, but that wasn't the beginning of the database explosion, because before that you had some other things happening, right? You've got MySQL as a database, you've got MongoDB, you've got Couchbase, you've got all these different open source databases. You have cloud databases now. Amazon has their own, you have DynamoDB. There are all these different databases. Well, on our show today, we have Steve from a company called Vertica. Well, the product called Vertica, it's now part of OpenText. I remember interviewing Dr. Michael Stonebreaker back in 2005, I believe it was, when he was just rolling out Vertica. And the reason they have that name Vertica is because it's vertical for column orientation. So a lot of people know if you go into Excel, you look at a spreadsheet, you have rows and columns. Well, rows typically contain lots of different types of data: first name, last name, phone number, email address, all this kind of fun stuff, notes. That's all in a record. That's one record. And then the columns tend to be the same, or they should be the same, of first names, last names, phone numbers, etc. One reason why that's important is because compression is easier on a column. And so Vertica was one of the first major column-oriented databases. It wasn't the first, but it was one of the first. There was Sybase IQ was one before that years ago. It was one of the first to say, you know what? People want to do analytics. People want to do analysis. Compression is a big part of that. And being able to rapidly slice and dice information is a big part of analytics. That's what we need to be able to do. So Michael Stonebreaker, who invented the modern database, by the way, if you look this guy up, he's amazing. Way back at MIT, like I think 50 odd years ago, he came up with the Postgres and the Ingress, which were database architectures that have now been used by tons of different companies. Well, I'm telling you this backstory just to help you understand how we got here. And what's fascinating is this data fabric stuff came really after the Hadoop movement. People started thinking, all right, we have these incredibly topographically challenging environments. How are we going to be able to provision across multinational corporations with many, many different users, sometimes tens of thousands of people? You'll learn in the database world, concurrency is a real issue. And being able to serve many concurrent users is a real issue, because it's like having 10,000 people come into your boutique shop someday. Well, you can't even fit them all in there. This is what happens with concurrency. You have to purposely design your architecture to handle that kind of stuff. And as my buddy Mark Madsen, who's an analyst again these days, once told me, he said it takes 10 years to find the edge case for a database that will crash it. 10 years, like after you're in production, before you finally figure out what is going to throw it off. All right. This is how complex databases are. So data fabric is even more complicated than that. I mean, quite frankly, it really is a whole array of data pipelines and triggers and monitors and sensors. Now we have data observability these days, which is all about watching for upstream changes in data. Did a field change? Is there a new column in this database? Did we not get the data? Well, these kinds of early indicators are very useful for data engineering teams and for analysts because hitherto you'd show up and start doing your query and you just didn't get the data that you wanted. Well, what the heck happened? I don't know. Let's look into it, like raise a ticket with IT and wait a couple weeks. Well, those days have to be gone, folks. And Data Fabric is designed to be able to solve for that. And then data mesh, as I suggested, well, it's a fascinating concept. Exactly what it is, I don't know. We're going to find out. But I think I've been talking for a while now, so I'm going to go ahead and pipe down and throw it over to Steve Sarsfield from OpenText Vertica. Steve, you've been around maybe almost as long as I have, or about as long as I have. So you've seen this whole evolution. And it's kind of amazing. It's kind of bewildering. But I do feel like we're getting to a place now where, at least to a certain extent, the nuts and bolts of the data administration don't have to concern the analysts and the end users who just want to have fun with the data. What do you think?
Yeah, absolutely. It's funny. I think over the years, what has happened is the data center of gravity has changed quite a bit, right? So it used to be that the data warehouse was the center of gravity, but we can't do that anymore, right? We can't just continually move all the data in the data warehouse. So we have things like data lakes, and we have object stores that we can store our data in. But the center of gravity has changed because the volume of data is getting so much greater, and we can't possibly load that in. The number of people who want access to analytics has changed. And so we have different challenges now. We have big challenges that we can have. And so really what data fabric and data mesh really represent is that change in gravity where the data sits, whether it's in locally object store, on the cloud, various places. I think it kind of represents accessing and managing and using that data not in one central place, right?
Yeah, and that's a really good point. And you bring up data lakes, and of course now we've gone from data lake to data lake house to lake house architecture, and just all this stuff. And I think the key is to remember the product, to focus from a business perspective on the data product. But I'm kind of reminded too of the NoSQL movement. So out of Hadoop, you had this sort of NoSQL, which meant not SQL, and then sometimes
not only SQL, right?
Only SQL, right?
Yeah.
Not only SQL. And what happened is very shortly after that, these NoSQL databases started strapping SQL engines on top of them. Right? Because guess what? SQL is a standard. That's the structured query language for those who don't know, SQL. It's a standard. And so you need that stuff. But I remember when the data lake craze came about, I started wondering to myself, are we making some of the same mistakes again that we made last time, where you just throw a bunch of stuff out there and then, okay, you hope to be able to find it, and people talk about the data swamp and things of this nature. And that's why you have people saying now lake house architecture. They're coming up with more clever ways to be able to get access to it. But that's really the bottom line, is access path and efficiency, right? Whatever your information architecture is, the key is you want to optimize the access path for the important users, and you want to be efficient and durable and secure and all that other stuff, right, Steve?
Yeah, I think we don't really have an ETL problem or ELT problem anymore, right? We're not trying to move the data around. What we're trying to do is access it in place. You're absolutely right about that, Eric. And so, we need to do some things in order to access in place. It could be data mesh or data fabric. And with a data mesh, we want to make sure that we have access to the metadata so we can access that data on top of the data and then perform our analysis. With a data fabric, that metadata may not exist, right? So we may have to create a semantic layer, our own semantic layer using a graph or some other technology. And so again, it's about accessing the data without having to move it into a single consolidated data warehouse.
Yeah, that's a really good point. And the metadata, so I talked about that in the semantics and data catalogs and some of these other things. They are all there to help us make sense of the data. And the other interesting development here from a business analyst perspective is that In the data warehousing world, we stripped out all the context to be able to get it through thin pipes to slow processors and be able to slice and dice the data. Well, you don't have to do a lot of that stuff anymore. I mean, I
Right.
do remember the schema on read concept coming out of the
Mm.
data lake. And even that's a bit challenging, right? Because it's going to slow the process down a little bit. You have to make sure you get that correct. But the general thrust I'm throwing out here is that you don't necessarily need to strip out so much context, read metadata
Mm.
anymore to be able to facilitate use down the road, right, Steve?
Yeah, that's absolutely true. I think that that metadata, that context is super important for the organization. It kind of describes how you use the data and what you want to do with the data. And so stripping that out can be, detrimental to whatever you want to accomplish in terms of business, right? We do these things because we want to understand our business better. We want to drive three areas. Area one is we want to make sure that we can drive additional revenue within the organization. We want to make sure that we're super efficient and using only the servers that we need to have and only the processes that we need to do. And we want to make sure that we're compliant. So if someone asks us for a report, we should be able to go out to those data sources and very easily get access to that. And so, having that metadata, having that sort of whatever it is, fabric or mesh or whatever, to allow us to access those data sources and perform those three things, I think is super crucial.
Yeah, we have got a couple of good questions from our studio audience, by the way. So I'm just going to throw this one out there. One of our attendees is writing, so does that mean that users would access the data at the source? That is usually not a good idea because it could put too much pressure on source databases, even with data mesh fabric. Don't we need to move the data to some central location for analytics access? And this is a good question, but I will say you are starting to see a greater focus on federated data access and
Yeah.
leaving the data where it sits, just to be able to touch it as needed. But there is a point about overburdening source systems. That's why we came up with these things in the first place, right? We realized that SAP ERP was not easy to query. And so we pulled data out of that, put it into the warehouse. But so what do you think about that? There is some concern, but I think the processes are getting more and more elegant and efficient at being able to do that. What do you think, Steve?
Yeah, it's a case by case basis. I know for Vertica, what we do is we do have data virtualization. So if you're, for example, you wanted to run a report and do a join against a table that's sitting in Oracle, that's pretty easy for us to do. And a lot of other databases have that too. So being able to go out and access that third party is key. It will tax the third party system though. And so what I see a lot of companies doing, if they're concerned about that, is they're leveraging object stores these days. So they're taking a lot of their data and just dumping it into an object store. That provides you with some pretty interesting capabilities. So a lot of the databases, including Vertica, has this whole concept of separation of compute and storage. So I have my data, it's sitting in a separate storage object store. I want to do some data loading. I spin up 3 nodes, I do data loading. I want marketing to run reports. I spin up 3 nodes, it does the reports. I want various, my dashboard's throwing really fast. I spin up 5 nodes for the CEO and I run the reports. They're all operating on that same data, but we're able to access that through one location, through one engine. And we see that happening a lot in the market. It's happening within our customer base, and it's a kind of a new way of doing an architecture, is that whole separation of compute and storage.
We're talking to Steve Sarsfield of OpenText Vertica and Eugene Burke from Digital Strategies Group. Eugene, you heard us ranting and raving about data fabric versus data mesh in the opening. And we had a great question around logical data models and where this is all going. I mean, when I think about these large language models, again, they have absorbed far more than just text. They have absorbed concepts. They have absorbed formulae, whole spreadsheets. One of my buddies was saying, he goes, I just go to these things to get the numbers of things because that was absorbed as well. Now, again, you do have this whole issue of moorings and anchors of truth, as some people call these things, and you have to worry about all that. But what's your take on the data mesh versus data fabric religious war, or is it that big of a deal at all?
So Steve, I guess I would have a 2-part question to get us started on this segment. Are data fabric and data mesh twin sons of different mothers? Are they destined to fight? Or do they have different objectives and different mountains to conquer? And how do they relate to LLMs and this kind of adoption of a completely different paradigm for enterprise ask and answer computing?
I can answer that if you want. I kind of look at data mesh and data fabric as I look at the origin story. Every superhero has an origin story.
Right.
I think data fabric and data mesh have different origin stories. So in the case of data fabric, the origin story has a lot to do with graph databases. Graph databases, to some extent, they are a solution looking for a problem. To some extent, I don't want to completely paint them like that, but the problem that they solve, the one problem that they really solve, is that if you have disparate data, and that data is sparse, and that data is it doesn't have any metadata attached to it, it's sort of like an unknown. Graph databases do a really good job of building linkages between the data. Data that's sitting in different files, data that's sitting in different columns and rows. And so graph databases do a really good job at that. Thus, data fabric. Eric mentioned the Hadoop model, and I think the origin story of data mesh is Hadoop. We have data that's kind of sitting in there in the data lake. We want to have access to it. We want to make sure we know probably that the metadata is accurate, and we know that maybe our company grew through acquisition. So I've got data warehouses that have multiple data warehouses in our organization. I've got a data lake in our organization, but the metadata associated with that is probably pretty good, and we can sort of kind of trust it. That's data mesh, and putting all of that data together is kind of where that comes from. So when I look at data fabric and I look at data mesh, I look at those origin stories, and it doesn't really answer, though, which one I should use. And so, if you kind of turn that around and you are a pharmaceutical company and you have a lot of disparate data, and the data is a little bit messy and it's a little bit sparse, maybe the thing to do is to set up a semantic layer, access that, and use a data fabric. If you're a company that has grown through acquisition, you've got multiple data warehouses, a CRM system, an ERP system, but guess what? The data is pretty good, pretty fit for use. Maybe data mesh is the solution. And I think that's the big difference in my head of what the differences are between those solutions. I don't know, Eugene, you want to comment on that?
Sure. I guess the follow on is, do you agree with some people's assessment that the data fabric is more IT driven and a data mesh is more business pull or business driven and organized around the business typology or topography? So, and what mesh is trying to solve is to put the business back in the data driver's seat.
Yeah, I think that's true. And one of the reasons for that, again, is the introduction of a graph database and a semantic layer, right? That's a pretty tough thing to do. It requires a specialized set of knowledge that not a lot of people have. Only a handful of people. And I'm trying to understand what Sparkle and Cipher is, and trying to understand basically what a triple is versus, a standard column and row. That requires specialized knowledge that we just don't have normally in the normal database world. So it is IT driven. It usually has a component of services and technology that are bound together that kind of work together to create that semantic layer. With data mesh, we can almost pull that off if we have a good understanding of metadata and how to manage all of those, and data virtualization and some of the other tools that you might use for a data mesh. Yeah, that's more of a business initiative.
Yeah,
that's my opinion. You guys comment like that. That's how I see it, though.
Yeah, I also have had difficulty wrapping my head around tuples, right? And I remember when the semantic web was going to solve all the world's problems, and it never really kind of got there. Now, there are semantic layers that you can use for a database, and that's a very useful thing. It's very similar to data catalogs, right? I mean, a data catalog is there to capture the meaning of things and to enable business people to connect dots in their systems, basically, right? I mean, that's what a data catalog is supposed to do. But again, these things are all it's just interesting how they're all sort of moving forward at their own pace. Although I'd never heard before until now, so thank you that the origin story of data mesh was Hadoop. I did not know that.
Listen, it may be wrong about that. All of these technologies, though, they kind of rely on multiple technologies, right? It's the coming together of multiple technologies. So we have databases, and databases that used to run data warehouses are having capabilities around data mesh, right? They're able to go and access data that's outside of them and perform analysis on them like they couldn't ever before. And we have query engines, Presto and Trino and some of those technologies. They can access data that's sitting in a data lake that doesn't have any metadata, it's not sitting in a database. Visualization tools, graph databases, data virtualization, data catalog. So a lot of those things are coming together as technologies to form data mesh, data fabric.
Yeah, that's a really good way to put it. A data fabric, I think, is the amalgam of all these different things.
Yeah.
And it is designed to be an efficient and thoroughly capable data foundation to handle whatever data uses the business may have, which is interesting too, because it's almost like we're moving in the direction of so-called HTAP, right? Hybrid transactional analytical processing, which always made me kind of wonder. There was this approach where a query would come in and you could have sort of a sniffer there waiting. It's like, okay, is this an analytical query or an operational query? And if it's operational, okay, I'll go this way. If it's analytical, I'll go that way. I wonder about that. Anytime you have these sort of if-then statements at the foundation of a database technology, well, that's going to affect performance, right? I mean, all this, when you get right down to it, has to do with performance. Can this thing perform the tasks I want it to perform quickly enough, efficiently enough, and accurately enough? And that's where I see tremendous pressure from these LLMs on basically everything that's in the data stack, everything that's in the information stack, because the key is to have your embedding strategy and to know, and that gets back to your point, Steve, from earlier in the show, that you as an organization, you need to start getting your data prepared for these large language models and make sure that it's trusted, make sure that it's governed, understand your processes. And one of the things that you can use to do that is a large language model, because they're actually pretty good at being able to ascertain and then articulate specific processes that you need to go to. It's really interesting. I was talking to Steve Lucas, the CEO of Boomi, former president of SAP Americas. He was over at Marketo for a while. He was saying when they got in there, he started looking at what they were seeing inside their own systems, and he asked it, show me all the different versions of order to cash that we have. It was like, okay, just started. He's like, holy,
yeah, a lot. Yeah.
Wow. So we're just now scratching the surface. Now, it doesn't mean all this other stuff is going to go away, at least not right away. But it does mean that you have to get your data ready. And that means quality checks. That means lineage checks, things of that nature. What else would you suggest, Steve, and then maybe Eugene, from your experience? How can organizations get ready for that? How can you prepare your data for large language models? First, Steve.
I mean, a big one for me is access and security, right? That is a huge one. A lot of companies have PII that's sitting out in a data storage somewhere. It may be encrypted, it may not be. How do you identify that PII and make sure that you're not exposed as a company to all of the potential fines that you could get around that? That is a regulatory mess that could, you want to make sure that that problem is solved. We have some technologies at OpenText that allow you to actually go and take a look at even free-form text, even video and audio, and allow you to access that and take a look and make sure that there's no PII there, so that you're not vulnerable to lawsuits and stuff. So security, access, encryption, that's a real key one for making sure that your data is in order for for the next generation.
Yeah.
Eugene, that's one I can probably go on, but Eugene,
So there are few things like an LLM for exposing flaws in your data. And exposing one of the flaws would be security holes. So to your point, if you have PHI or PII and the LLM has a way to find it, it will find it, right? Because that's what it's built to do. And so now is the time to understand your IAM architecture and to make sure that if you're going to use a large language model for customer service, patient service, provider service, that you really understand the pathways for accessing your highly sensitive data. And because you don't want to have an audit come up to say, okay, here's violation, or God forbid a breach, right? Because you didn't adequately think through your architecture.
Yeah.
So that's a technical component. There's also sort of like the operational components of it, right? With data governance, we used to talk about people, processes, and technology. And so the people and the processes are also something you need to look at. How is data handled? Is data copied? Regarding processes, and then people who has access to it. How are they handling it, and so on. So again, there is a component of data governance to data mesh and data fabric.
So the mixture of a Wild West data culture and LLMs is quite potentially dangerous.
Yeah, that is true. The other cool thing here, and some of the cooler technologies I've come across, have this capacity to scan your environment. Some of the data catalogs have this capacity. Very, very useful stuff. There's a company, it's really more in the security and governance space, ExtraHop. I haven't taken a briefing from them in a long time, but what I loved about them is that they will scan, they basically just siphon off your network traffic and then create a digital twin of your entire information landscape to show you every database, every application, anything that's touching it, you see an object for that. And that's the kind of tech that you can use. And of course, LLMs, I mean, like we said before, if you point one at your information architecture, it's going to start sucking that stuff up. And if you weren't careful about what went in there, it's going to be very difficult to get it out. It's like unlearning things. It's hard to unlearn something. And I often use the analogy of raising children to explain how to train your large language model. If you've got a 2-year-old, you don't want to let her hang out with a bunch of gangsters in the hood for a while, because they're going to absorb all this information, these behavioral patterns. So you have to be careful about how you train, what access you give to these models, just as you do raising your child, because all of a sudden your kid will be reflecting things back to you that you don't like, and you're like, well, where did that come from? Well, I don't know. Where did you allow this child to go? What did you share with this child? Well, just funny story. One of our babysitters watched with our, I guess, 3-year-old, the Chucky movie, like the Chucky, the little killer, and we're just like, all right, why did you do that? Now our kid loves these really dark, disturbing movies. We're like, all right, I don't know if that was the best move on our part, but once it's in there, you're not going to get it back out unless you like unplug the whole thing and start from scratch. That's not going to be fun. That's not going to be fun. And I think that this is a major trend line that we are going to see here over the next number of years. It's going to be very interesting.